8. Why is the situation in the East Siberian Arctic Shelf, ESAS, so threatening? ESAS stands for East Siberian Arctic Shelf, an area of over 2 million square kilometers large on the edge of Siberia. ESAS is the largest continental shelf in the world, and 75% of the sea over the shelf is less than 50 meters deep. At the last glacial maximum, LGM, at the height of the Ice Age about 20,000 years ago, the sea level was approximately 120 meters lower than it is today. The ESAS was well above sea level, and the cold air temperature would have cooled the land surface to considerable depth, freezing water around organic matter into permafrost. Then the sea level rose, and the land and permafrost were inundated. Some of the organic matter would have decomposed, producing methane, which could, at certain pressures and temperatures, combine with groundwater to form methane hydrate, a lattice of ice and gas. Thus, below the permafrost is now a mixture of hydrate and free methane gas. Methane release from the East Siberian Arctic Shelf and the potential for abrupt climate change, by Natalia Shakova and Igor Semilitov, 2010. A recent paper in Oceanology says that the ESAS is not only the broadest and shallowest shelf of the world ocean, but also undergoes pronounced transformations under the change of climatic epochs. The shelf is also characterized by the location of over 80% of the existing submarine permafrost, as well as of the bulk of shallow water gas hydrates. The most distinctive characteristics of the Arctic compared to oceanic gas hydrates are the following. High density of the spatial deposition. The thickness of the layer of pure gas hydrates may be as high as 100 m or more, unlike the oceanic hydrates occurring mainly in disseminated form. The presence of deposits is more likely by several times at the Arctic shelf compared to the Arctic land. The high interstitial saturation with gas hydrate, from 20 to 100% of the interstitial volume against 1 to 2% for oceanic gas hydrates. The lower thermal capacity of the phase transition, a third of that for oceanic hydrates, and high sensitivity to further warming, because of the profound changes in thermal conditions of the submarine permafrost proceeding as long as 5,000 to 6,000 years. The degradation of submarine permafrost and the destruction of hydrates on the shelf of East Arctic seas as a potential cause of the methane catastrophe. Some results of integrated studies in 2011. http://link.springer.com/article/10.1134% sign 2 FS 1028334X120801444 number sign page -1 Sam Karena discusses further points at the methane hydrates blog.